There are many literacy demands throughout the math content area. Students must be able to read and understand these texts that use language in discipline-specific ways. Math textbooks present information in linguistic, symbolic, and discipline-specific ways. These texts are generally multimodal and may require students to comprehend multi-ways of representation to understand just one problem. Students may have to read a word problem, use information in a graph to find the necessary numbers they need, use a formula to solve, and fill in the remainder of a chart when the problem is completed. Math materials require their own specific reading purposes and strategies. Mathematicians must be able to use text structure and their background knowledge or schema to ensure their understanding. In the article, It's a Different Kind of Reading, Two Middle Grade Teachers Evolving Perspectives on Reading and Mathematics, the two middle school teachers had background experience in both reading and mathematics. The study wanted to capture how this would impact their teaching, whether the strategies learned to teach reading were sufficient to teach math, and if not, what strategies would be most beneficial for teaching mathematics. In addition, they wondered if this could help bridge the disconnect between literacy specialists and subject area teachers, a topic that will be further explored later in the PowerPoint. One of the teachers, Sarah, explained, "Mathematics texts include tables and graphs and other representations to be read and interpreted. These are a type of text that requires us to read vertically as well as horizontally, and possibly diagonally, to read titles and headings, and to read the data displays related to a chart or visual display. It may require reading right to left as well as left to right. It's another genre of reading." Even with a background in reading, these teachers had not learned how to teach reading mathematics texts. When the study initially started, the teachers were interviewed and felt that the reading simply got in the way of learning mathematics. The teachers would read the problems for the students, as the students would get lost in the verbiage, quoted by the teachers before the study was beginning. They explained, "It's interesting to try to figure out what makes the problem so hard. Is it that the students don't have the skills behind it, or is it that they just don't understand the language? You need to have a vocabulary, and you really need to focus on individual words." But I'm not always sure that it's the individual words that are hurting them. I think it's the putting it together and packaging that's the real reason why they struggle. If my better students struggle, well, this isn't just a reading level problem. There's something else going on. Quoted by a teacher before the study began. Teachers would originally pre-teach instead of instructing students on each individual concept, as this reading was viewed as problematic for their students' learning, instead of something available to support their learning. They consider the problems to have unnecessary wordiness. Something had to change in order to enable students to better understand the reading that was required in their mathematics texts. After all, mathematic instruction, especially when solving word problems, is related to performance in reading comprehension. If students cannot understand the language, they cannot understand the concepts they need or the questions being asked. This study set out to explore what strategies students could use to benefit their understanding. "I used to do all this pre-teaching and now I get it." No, you're not supposed to do any of this pre-teaching. You have to go into the inquiry and then build the concept from the inquiry and add on to it. Within the inquiry, you can develop the skills that are lacking. Quoted by a teacher in year 2 of the study. The teachers started integrating more questioning into their teaching. In addition, they began teaching students how to write, revise, and edit texts that included explanations, definitions, justifications, tables, and graphs. They taught students when reading a mathematics problem, they need to set a purpose. Students need to understand the directions and what the problem is before taking any further steps. Students were encouraged to read and reread the words, pictures, and diagrams to promote their understanding. They were told to go back and forth from visual and written information to pair their understanding of both. Early on, the class would even read together and place information in a relevant or irrelevant column in a T-chart. Next, they were encouraged to highlight important information only. Students could also work with a peer to evaluate the correctness of their representations, similar to a strategy used by mathematicians reading disciplinary texts to evaluate them for correctness. An example provided by Shanahan and Shanahan. Finally, the teachers introduced the 3-pass strategy for students to remind them of their steps. Look for the purpose, examine or make pictures, then pause and check before answering the question and ensuring it makes sense. Despite having a background in reading, one of the teachers, Tracy, admitted that without the collaborative support of the researcher, her understanding of the pedagogy would have been incomplete, and she would not have known how to restructure her teaching. You will learn more about these supports later in our PowerPoint.